Okay, so this problem says the electric field in a region is pointed away from the z-axis. So here's the z-axis, and it's pointed, it points radially away from the z-axis. The magnitude of the field is given by alpha s, where s is the radial, it's the radial distance. Alpha is a constant. Find the potential difference between points P1 and P2, explicitly stating the path over which you conduct the integration for the line integral. Okay, so if you check your notes, V2 minus V1, the potential difference between points V2 and V1 is given by minus from 1 to 2 E dot ds, this line integral. Okay. And you can take the line integral along any path. Since it's a conservative force, the value of the line integral will be the same. Okay. And so we will choose the path like so. What we'll do is we are going from 1 to 2, so we'll go from there. Okay, so this will be our initial point, this will be our final point. Okay. And you'll see in a second. All right, so you guys familiar with cylindrical coordinates? Cylindrical coordinates are rho, p, z. Okay, and so here are the cylindrical coordinates. X, Y, Z. This angle is phi, this distance is rho, and this distance would be z. Okay, so rho, phi, z. Okay, so the coordinates of this point are phi is this angle, rho is this distance, and z is that distance. Okay? So that's what those cylindrical coordinates are. Okay, and the unit vector in this direction is called rho hat. So the electric field is alpha rho hat. Okay, so here they've used S, but the standard notation is rho, so I've changed that to rho. Okay. Now notice, so when you do this line integral, when you're traveling along this direction, ds is in this direction, rho is in that direction, rho dot ds will be 0. Okay? So along this path, this is 0. Okay? If you want, so I don't know. Okay, let me. So along that path, here is ds. There's the origin, and ds. This would be rho d phi. So E dot ds would be alpha rho hat dot ds is rho d phi hat. That's what that works out to. ds, the distance, is rho times d phi. Okay, and this is 0. So what we are saying is along this path, this integral is 0. So now we just have to do the integral along this path. Okay. All right, so let's do that one. So I'm going to write this expression. So V2 minus V1 equal to minus, so along path 2 now, and now we'll call this point 1 prime. Okay, so we are going from here to there. So 1 prime to 2. And when you're going along that path, when you're going from there, you're going from a radius of rho 1 to rho 2. Okay, so this integral becomes rho 1 to rho 2 alpha rho d oops, rho hat, that's E, dotted with ds is d rho hat. Now when you're going along this radial path, ds is just d rho hat. Okay. And the integral is from a radius of rho 1 to rho 2. Okay. Rho hat dot rho hat is 1, so this integral is just minus rho 1 to rho 2 alpha rho d rho. Okay. And integral of this is natural log rho and rho 2 to rho. All right, so what we are saying is the following. So let me go back to this diagram. Okay, so here is a top view. So here is the origin, and these are the various radii. Rho 1, rho 2, okay? And the electric field was, remember the electric field was pointing in that direction. Electric field points in the direction of decreasing potential. So potential at this point should be higher than potential at that point. V2 minus V1 should be negative. There's the negative sign. There's the negative sign. Alpha is positive. Rho 2 by rho 1, that's greater than 1, so this number is positive. Okay, and so you can see that explicitly this shows you that V2 is less than V1. Okay. And if you calculated, if that was V2 and this was V1, if the radius decreased, if this was smaller than this number would be negative and that would become positive. Okay. All right, so that shows you. So here's the main point of this, well, here's one of the main points of this problem. Okay, this line integral is independent of how you get from there to there. You can choose any of the paths, and the value of the line integral is the same, meaning, and that's true for conservative forces. So the electrostatic field is, the electrostatic force on a charge is conservative, and so that line integral turns out to be independent of the path. And so we chose a smart path. This was the right path to choose. Okay? where you could do the integral, where this was easy. All right.